Great. And we'll go ahead and get started by enabling everybody to be able to share. I'll share this screen. The first things first is, can everybody see the processing download screen? Yeah. I'm going to go ahead and just put this link in the chat. If you haven't already downloaded it, it can be useful to actually use processing on your own computer. And there should be download links for Mac, Windows, and Linux. But if you don't have it, it's a super quick download. It shouldn't take up too much space. But let's get started with processing hour of code. Daniel Schiffman, an icon. He's a hilarious guy. He's also just such a great coding programmer, but also coding educator. So highly recommend you check out his stuff. But here we go.
To code, let's take a moment to look at a range of projects, things that have been made in recent years with computer programming for the visual arts. This is Strada number 3 by Quayola. Quayola is an artist working in London. This animation combines computer-generated images with video of a cathedral in Rome to create a fantastic new reality. In his own words, he is investigating improbable relationships between contemporary digital aesthetics and icons of classical art and architecture. This is Oasis by Yoon Sil Ho. She is a media artist working in Seoul. Oasis is an interactive installation. By moving around the sand, small pools are created where new software creatures are born and live. This is Replica by Alex Vessels and Jeff Howard. Alex and Jeff are interactive artists and designers working in New York. Replica is an interactive dance performance that uses live image processing to explore how the awareness of time and captured images affect self-perception. It was projected onto a 120-foot video wall in New York. This is Unnamed Sound Sculpture by Daniel Franke and Cedric Kiefer. Daniel and Cedric are media artists working in Berlin. This animation is a moving sculpture created from the recorded motion data of a live dancer. These animation and installation projects are just one way that visual artists are working with code. More traditional design areas such as map design, brand identity, and logo design and illustration are transformed through designers writing their own code. This is the Density Map by Fathom Information Design. Fathom is a design studio in Boston. This map uses circles of different sizes and colors to visualize population density in a unique way. Larger, darker circles show areas with fewer people, while smaller, brighter circles highlight crowded cities. By glancing at this map, we quickly get a sense of how some cities and countries are more densely populated than others. This is the logo for the MIT Media Lab, created by the Green Isle. The Green Isle is a studio based in Berlin. The identity system can be used in different ways in many contexts, including the lab's website, business cards, and in any other media. It forms a mutable identity that is synonymous with the Media Lab's approach to the ever-changing nature of technology. In addition to the kind of work we're looking at already, there's sculpture, fashion design, architecture, products, jewelry, pottery, much, much more. What does writing software have to do with these physical objects? Everything. It's an area of exciting and emerging possibility. New technologies make it possible to print objects. For example, it's now possible to design a ring in software and print it in plastic or metal. Let's look at 3 final examples before starting to learn how to code. This is the D-Dress software by Mary Huang. Mary is an entrepreneur and designer working in New York. D-Dress is a program written by Mary that allows a user to sketch a dress and then automates the pattern creation. It reimagines the classic little black dress by changing the relationships between manufacturing, the designer, and the wearer. The textile room was created by the architecture studio Patterns, founded by Georgina Olhik and Marcello Spina. Georgina and Marcello are architects working in Los Angeles. The textile room is an experimental media space where carbon fiber textiles are augmented with a video collage. This is Cell Cycle by Nervous System, a design studio founded by Jessica Rosenkrantz and Jeff.
That's a bunch of examples that I wanted to show just because it's a lot of cool, real life things that actual design studios are doing. And then Daniel goes on to explain that actually all of those things that you just saw were made in processing and then exported into a website or, as a exe file. So some really, really cool stuff that you can do. Anybody have any thoughts, questions, things they want to add before we jump in? So if you have processing downloaded, what we can do is just open up, double click it and open up an empty sketch. All right, let me just show you. You can do that by finding processing on your computer, double clicking it or opening it on whatever application you have. You can do file new and it should open up just a blank document that looks like this. It can be helpful to split your screen, twice, and I'll try to organize it so it's less confusing for everybody. I'll try to make it nice and big like that. Everybody, give me a thumbs up if you have that, or if you don't want to do that, you just want to watch what I do. Great. So this is your processing environment. Really what processing is, it's not really a coding language. The language that it uses at its core is Java. What it is, it's a platform to simplify the process of using the visual aspects of writing code to then write it, display it in a very consistent and concise way. What I mean by that is there are built-in functions and built-in calls that you can make that make creating objects and shapes and different visual characteristics very easy. For example, in our first thing, sort of the hello world in processing, is to just write the word ellipse, or spell it right, ellipse. And then this is a function call, so start a parentheses to open it up. You can give it some parameters. For example, we'll just say 50, 50, that's its position on the screen, and we'll make it 80 pixels wide and 80 pixels tall. Close the parentheses and close the semicolon. You can hit run up here, and it should bring up a little screen somewhere. Let me pull it up. Shut up on my other screen. Come here. Why did I move it over? You guys should have seen squares pull up somewhere. Sadly, I can't move it over yet. Did anybody see a circle pop up on the screen? Beautiful. Yay. All right. Super simple, super basic. Congratulations, you made a circle. But what we can do now is start to take control of the canvas that we're drawing on, and then what that circle or whatever we're drawing actually does. So, in processing, the way it's set up is that you always have typically two functions that always exist in your program. You have a program that's called setup, and you have one that's called draw. So setup is executed once at the very beginning. It either declares all your variables, or it tells the program, how to set up just the, how big your screen is, what colors you're using, things like that. And then your draw works over and over and over, infinitely until you close the program, and it actually draws the things you're trying to do. So in our case, we're going to do void. That just declares that we're calling a function or creating a function. Setup, just like that. Just empty parentheses, open bracket, and then you can do a close bracket. And we'll just type in size. Yes, size. And this is the size of our canvas. So let's just make it 500 pixels wide and 500 pixels tall. And then now it's giving us a little bit of an error because once we call setup, it also wants us to call draw. So we'll do void draw, open and close parentheses, and then open bracket, and then down here we'll do a close bracket. And then all the errors should go away. I'll go ahead and just type this into the chat here. So if you do that and hit run, you should see, here we go, a screen pop up, a gray screen with 500 by 500 and then a circle right at the beginning. Give me a thumbs up if you got that or if you had trouble. Almost got it. And if you're not purposely not following along, let me know so I don't have to wait for you. But if you are, I want you to follow along. Great, thumbs up, thumbs up. Awesome. So there we go. We clearly have a drawn circle on a background, but it's not really interactive. It's not really doing anything. We could definitely change the location by making this be 250 and 250 to be right in the center. So if we hit stop and then run again, we should have the screen come up. You should see that the circle has now moved to the very center. You can also do something different, like up here before you write ellipse, you can write something called fill, and you want to make it white completely. So you can say fill, or completely white is going to be fill 255. That just says fill whatever comes next. So fill the ellipse. We'll hit run, and now it's completely white. Let's say we want it to be completely black. We'll just do 0. Run again. No, this is super basic, but we'll make it fun in a second. Cool, completely black circle. What we'll do now, I'm gonna get rid of that fill, is actually add some interactivity. And so there's these built-in functions that in other languages like Python or JavaScript, you would have to import libraries, import some function calls. But in processing, you just say mouse this, and it knows that it means, hey, when your mouse moves it like this way, or when your mouse clicks or right clicks or whatever. So in the first 250, so this is X position, Y position, X height, or X width and Y height. In the X position, type in mouse, lowercase mouse, capital X. And then we're going to run it. When you pull it up, what you should see now is that whenever you move your mouse on the screen that comes up, you're now actually drawing new circles every time. Give me a thumbs up when you've got that. Woo! Awesome. So if we stop that, well, if there's a mouse X, probably there's a mouse Y. So we'll replace that second 250 with a mouse Y, capital Y. Start. And now you've got your first brush, which is sort of like a worm creating thing, which I think looks kind of cool once you fill up the screen completely. So if you go pretty fast, you see circles. If you go slower, you start to see a little bit more of a texture. People got that? Hell yeah. Good stuff. Already, like, me personally, like, I know I'm not gonna like publish this to the MoMA or anything, but I enjoy just kind of like canoodling this little like snake cursor, because now it looks like we've got like an art project of pipes and things that can move up and down. So I'm already having fun. Seems like art to me. So let's see how we can make this a little bit more interactive and complicated by clicking on mouse. So let's start a conditional statement. In processing, it's very simple. You just write if, and we're just going to write mouse, capital P pressed, like that. And you should know that it's a built-in function because it turns a different color. In my case, it's pink. If mouse pressed, then we'll close that. Open bracket. We'll say fill to black. Close bracket, and then else we'll just fill it to white, which is 255. We'll hit run on there. And now you can drag your circles around, and now if you click and hold it, you should see that it turns black. Give me a thumbs up if you were able to get it to turn black. Sweet. All right, but unfortunately, it looks like whenever we're drawing in black, it also has a black border, so it just looks like a really thick black marker. So we're gonna close that, and let's fix that. And so here, fill is what the infill, but the border is actually defined by what we call stroke. You write stroke 255. That'll give it a white border, and this will actually cause a glitch that will be interesting to see, but it's actually really easy to fix. So I guess it's not really a glitch. So yay, now we have our white circles, and then click, we've got black circles with a white border. But then if we unclick, you see an all white marker again. So does anyone know what to do to fix that?
Stroke 0.
Yeah, stroke 0 on the else state. So now it'll reset basically all the markers. Woo! Coding 101. So now we've got an actual little marker that we can go around and make it do different things. Is anyone really proud of their snake? I like to fill my screen up. Sorry, I'm really OCD about this. All right, there's my screen. Art. I've made art. There's the first one. Oops, I fucked it up. Okay, so I'm gonna stop that. So that's a super bit simple setup, and I'll paste the code in here in case anyone didn't get to write it in. But that's basically a super simple way to get set up. You've got interactivity, you've got a brush stroke. And what's really nice about processing is that they include lots of examples internally that you can use to start inspiring other ways to create interactivity or other ways to incorporate coding elements. So I know a lot of you, I already know a lot of you, and I know that you are very familiar with coding. And a lot of the same coding principles like object-oriented programming, lists, arrays, mutation, all these sorts of things come into play when you're doing visual and artistic programming. Just you're able to apply them in ways that are pretty fun. So actually, let me pull up my list of examples that I want to run through. So if you go into processing, you hit File, and then go to Examples, and then you open up let's see, where's my examples sketchbook? Let me drag this over here. And then you open up, let's see, it's going to be in input, and then go to mouse 1D. If you double click it, it'll pull up a processing sketch that looks like this. And it explains exactly what it does. And without reading code first, we'll just hit the plus or the play button and play around with it. And basically what this is that you have two squares, right? So the mouse X direction, or the X dimension, controls the depth and brightness of the squares. So, right, so this gets, it goes darker and gets brighter as you move to the right, darker and brighter as you move to the left, and it switches them off. And if you look around in the code, you can actually see how they do that. So they call this thing called color mode, RGB, and clearly that's a function that will change the color of whatever object you're dealing with in both its height and, I guess this is a variable called height that will change later. Actually, this is height referring to the height of the actual width, or the canvas. And then here it says that sets the background to black. It says, map the mouse X to the width and the height, and then decide exactly how big or small those are going to be, right? So a super simple example, but still very effective. And then they go even further by doing mouse 2D. You double click that one. Mouse 2D, there it is. This one now adds an X and a Y element. So if we pull over here, now you can move it up and down to switch which one is in the foreground and which one's in the background, and left and right to sort of create this cool little effect of, like one zooming in and the other zooming back out. And honestly, like, this is, for me, all these examples is enough for me to play around with and start coming up with ideas for like different projects or fun little things. Are you having fun playing around with this? Yeah, I'm glad. Because honestly, like, I could just noodle on this for hours, and this is just like one of the first examples. Like the next one I want to show you, this is a fun one, is called mouse functions. So if you scroll down, mouse functions, pull up, play on that one. This one is just a super simple drag and drop. So once you hover over it, highlights, and this one you can click it and then drag it off. So this illustrates how you can do this in programming. And what's really nice about this is that if you are ever making an interactive environment for research, or maybe you're making a website, processing actually has versions of processing that you can use in the browser, in iOS, in Android, and even in Python. It's literally called p5.js, or processing5.js, processing.py, processing for Swift, like all these different versions of processing that they created that you can then easily use to write code to do this artistic stuff. And I promise we're going to get into some like really, really cool stuff that is outside of these examples. But let's keep going through the examples because they're so fun. We're going to get to my favorite ones too. Mouse, let's see. Mouse, next one that we wanted to show. Oh, mouse press is another good one. And some of them are going to be super basic, but this one is another type of brush. So this one, it's the same thing as like where you have the X, Y position determines where it's actually drawing, and then if you click it, it turns white. And then you can start to make some pretty cool looking shapes. And this is literally just a cross that they turn into a brush. So obviously, and you can look at it, they did that, they just said, instead of ellipse, they just said line and line for a vertical line and a horizontal line. But you could replace this with rectangles, you could replace this with like a polygon that you define, or a circle, a mixture of shapes, and then all of a sudden you have like a very unique brush. It's a lot of fun. So my favorite little example that I want you guys to play around with is called, open up the example under input, called storing input. Basically what this one does is it's very similar to the first we created, which with that circular brush, but instead it deletes the sums from the past, but still retains it in a delayed fashion. So you end up with this cool sort of like tail effect. And while this could look like a cool little animation, really it's you can look at it, it's like 25 lines of code, and it basically says it's just an array that stores the last couple of circles and then deletes the other ones and then fades the other ones out. So if you go really quick, you can start to see all the individual circles, but you can sort of see how you can mess with it. And what's great is you can play around with changing the different numbers of these or the different parameters of these sketches. So if you go to int num, and this is the value that it stores. So if we change this to just 20, and then ran it, you can see that it's actually stores a lot fewer, and it's like really fast little, little thing that follows your mouse. And like this would be a cute little thing to have anywhere or in the browser or anything like that. Similarly, if you change it to 80, it would create like a super long tail of stuff. Yeah. This one, honestly, I've just stared at it for like a good 10 minutes, just being like, wee. So that's a cute little thing. Another good example that is now going into a little bit of different things. So let's say you're interested in applying mathematical functions into your code and using, there's also so much overlap between natural occurring phenomenon in mathematics and art. So if you go into this math section, let's do additive wave. This person basically, oh, this is actually Daniel Shiffman. He does all this sort of stuff. He basically took the wave that is, let's see, here, like a cosine wave that he added certain parameters to, and turned it into a sort of moving animation that looks kind of like that. And there's your typical standing wave. Right? And you can add more cosines, and you can add stuff like that. You can do the whole Fourier transform stuff. If you go into the examples and open up, oh, this is a fun one. Open up arctangent. So what this person did is they took these, these circles that appear, and each of these circles is multiplied by an arctangent to then define where they look at or where they're pointing to based on where your mouse is. So the effect that you get is that you have eyeballs like looking at your little mouse, right? And like literally this is just like 6 different circles. 3 of them aren't moving, 2 of them are just following your mouse like that using an arctangent function. Again, this is another 50 lines of code, right? Like, so not super complicated. But what you can do, and I'll post this link in the chat in a second, is do something like what this artist did. And we're going to dive into open processing in a sec. Come on, load. Here, I'll post it in the chat in the meantime. So this person did the exact same thing, but with like way cooler looking eyeballs. So that they just spent a little bit more time shading the eyeballs in a fun way and making them move all dramatic and creepy. So this is like somebody's art project, right? Pretty creepy. And what's cool about this is you can also look at their code that they use. And it like pretty much is the same thing up here, except of course then they go on to translate the eyes a little creepier. Back to the examples. Creepy eyes, yay. Last example I wanted to show was going to be in array list data. So go down to advanced data and then array list class. And this one basically just creates a bouncing ball on the screen. And this is how you can start to add a little bit of physics into your animation. So if you click, 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 it creates a bouncing ball. So what's great is if you have a background in math, or if you know how to implement physics equations into code, you can do that same thing and start to create some really fun looking animation effects directly in code. So anyone have any thoughts or things they want to comment on? Or which one was your favorite one to look at? Anyone have a favorite?
Yeah, the tadpole one was pretty cool.
That's a good descriptor. Tadpole where he like follows you. Yep. That one's for sure my favorite too.
Are there like easy ways to stream data like into processing?
Yeah, there actually are. So if you go back into examples, this is especially in advanced topics, you can even do, so you can load things from XML tables, from Excel tables, from JSONs. You can even use APIs. So this is an XML Yahoo Weather example, and I haven't opened this one in a long time, but I'm pretty sure it loads a document that in theory you could scrape from the internet or use an API to get. And then let's see what it does. I think it just creates a weather animation. null pointer exception. I probably don't have this file because I messed up my processing. But short answer is yes, you can stream data into it. And you can stream different types of data, which is another cool thing. Oh, let me get rid of this.
So if I had like a Raspberry Pi or something, I could totally like hook a sensor up to it and just...
Yeah, and they actually have a version of processing that you can use in the Raspberry Pi. Okay. Let me, in the examples again, you can import photos. So you don't have to like always create your own images or drawings. So you could definitely do something like this person did. And let me grab it. So they created a little like animation using a photo that they drew in something else, and it just like flies around the screen. But you can also import camera footage. So people have done facial recognition algorithms and art, things like that, or feature detection using processing that you can use. So there should be another set of examples. Here we go. File input output, literally, creating a GUI using motion, using different, like, here we go, like literal OpenCV. Oh, this is what I found, right? So anything you can do in OpenCV, you can also do it in processing, right? Using an OpenCV for processing. What's nice about it is OpenCV is, notoriously hard to handle for just doing, the cut and dry facial recognition, machine learning with computer vision stuff. But what's nice about importing it into processing is then all of a sudden you now have a interface to overlay all these artistic elements onto the things that you use for OpenCVs, which I think has a lot of fun things that you can add and do to it. Any other questions? So now what I want to do is show you guys this really cool thing that actually Saram showed me, which is this website called Open Processing. And of course, front and center, they have this thing called stating coding is beautiful, because it is. And it basically is a platform for artists and designers to post their coding sketches that create some interactive or artistic element that they can do. And Open Processing actually has tons, you can explore the sketches, which we'll do in a second. But if you're interested in a specific type of visual media that is done with processing, you can actually search for it through here. So they have particle systems, and all these are similar to the things that I showed you. Balls flying around and behaving in different ways. Games. So this is like, this. Let me show you this person's. So this is a shooter game that somebody made in processing, which is pretty dope. Brushes. So this is similar to something that we made, but you can see over here that there's tons of different cool brushes that you can see. And then if you go over to the Discover tab, it'll actually show you whatever the most recently trending, most liked sketches are. So I went through and I curated a couple for you guys. We'll go through my favorite ones. So I'll just paste them in the chat as we go so you can play around with them too. So here's the first one. This one's called Planets. Or Orbits, my bad. So this person using processing, drew an ellipse. So they made a little circle. They've got this planet orbiting around, I guess, Saturn. Maybe it's one of Saturn's moons. What you can do is, this is super simple. If you click, it adds a second orbital. If you click again, it's a third. And they're all randomized in their speed, so they're just going to start doing all this fun stuff. And my computer's being a little slow probably because I'm running processing in Zoom. But you can click 30 more times, and it's going to add a bunch of different planets. And this is just a cool little visualization that we have. Has anyone played, or does anyone play Pokemon? Yeah, everybody. All right, so somebody made a sketch called OTID, which is just ditto backwards. And what they did is they made this cute little ditto looking thing. Oh, and let me paste it in the chat for you. This is OTID. They made this cute little ditto thing. What you can do is just like click somewhere on the screen, and it'll like nudge ditto in that direction. So then eventually you can just create your own, ditto shaped thing. So this, I got pretty close. This looks kind of like ditto. Or you can make like an abomination of anything you want. And in theory, you could hold to click and create a cavity. So now ditto has pants. So this is just like, but what's really nice is that they have this cool little, swaying animation, which is nice. And again, you can look at their code and see what it is they did. This one seems way more complicated than a little ditto thing, but that's what it is. All right. One that is similar but a little less interactive to what we did is this one's called like Flying Colors or something like that. This user is posts like a million things on open processing. All their things are great. Just a very nice, very soothing to watch. Like I could put this on an iPad and just let it sit in the background and see. It really add like a vibe to my room. But you know what they do here is they add an element of randomness to the code. So you can what they do is they select a random height, random width. They add this like noise variable, which is multiplying the randoms by some predetermined amount, and they use those random numbers that they get to generate both a size, a color, and where's my circles? There. A size, a color, and a direction and a velocity for these things. So if we refresh this, there we go. And that's actually a very common thing that you'll see done. And it's something that is referred to sort of as, in some sense, generative design, because it's generating, based on a set of predetermined constraints and principles, different artistic patterns and phenomena that just look very aesthetically pleasing or maybe accomplish something, right? And it's very likely that I'll never see this exact organization of colors and speeds ever again. But that's sort of like the beauty of it, right? Is that it always creates something unique. There's tons of these that exist. And by using this element of randomness, you can accomplish even more of that. This is another weird one that somebody made. Let me put it in the chat. It's called soup cans. Chat. Oh, I see the chat. There's the chat. Here's soup cans. So this one uses a little bit of physics and a photo of the what's the brand? The classic Campbell's tomato soup cans. What you can do is use the arrow keys to zoom in or zoom out or move it left and right. And then once you do like an abrupt move, it'll like explode the cans in whatever direction their axis is going to turn on. So I don't know why this person like is obsessed with Campbell's tomato soup. But you can like zoom in on the soup cans and eventually they'll like slam against the screen. So I'm just going to slam in real quick. Yeah. Campbell's tomato soup. And it bounces off. That's kind of a dumb one, but still somebody took the time to make it. Another fun one is, oh, okay, here. So we're starting to get into the ones that we can interact with. These honestly, like fully, I consider this a study break because it's an opportunity for you guys to just like play around with the stuff that you like, and also learn about different things you can do. So this one is one by an artist whose username is Takao, and this is again just like randomness, right? It keeps it after a certain point, it just like resets the number of triangles and ellipses and conical shapes. But like this is so cool. Like, this looks like something that could be in a museum, but it just disappears and creates something else. Let's take a look at their code. Yeah, again, not even 100 lines of code. That's crazy. And it looks like again they just use a color palette. So something I wanted to show you all. Coolors. If you go to coolors.co, this is a website by a programmer and designer who basically just like made it really easy to select unique or interesting color palettes. So they call it a super fast color scheme generator. And if you explore palettes, you can either create your own based on the emotions that you want or the vibe that you want, or you can just like see what's trending and just take the colors. And they actually give them to you in hex. So if you're looking for, this is like a vibrant modern one, these are the hex codes that you want. So in theory, if we went over to this person's, what is this one again? I already forgot. Oh yeah, let's use a more different color palette. What's one that people like? That's a cool one. So F72585. Oops. Let's replace some of these. F72585. 7209B7. 7209B7. And 4361 EE. 4361 EE. Okay, let's see what that looks like. Who knows? Yeah, this is so good. I love it. So you can just like change around your own colors and honestly like copy people's code and use it on your own stuff and like modify things. Like no artist truly makes something like fully unique. They always take from other people, which is encouraged because that's how we make new things. So that looks pretty sick. I kind of like that. Let's do another one. Oh, this one's really dope. Oh, did I give you guys the link to that one? Let me post it in there. And then this one that I'm about to post is called Frozen Shader. It's a very similar style, but it's another brush type. It's frozen brush. Basically, it uses this theory of where is it? The Delaney algorithm to create like crystals. So as you drag your mouse, it creates this like really cool generated mesh of crystals that you can have on the screen. And then if you hold down the spacebar or something, it actually fills them in, and you can see new shapes appear and do things like that. Or you can release it again or click it. You can just see the mesh. Like that's already pretty fucking dope. Honestly, it makes you think like how do you make this, right? Like literally like who thought of this? And again, like the actual like function is only 143 lines of code. This is the Delaney algorithm, which is quite a bit bigger. So we're not gonna really get into that one. But I think it's still pretty cool. Tangled. Oh, here's the ones that you'll probably want to keep. So Tangled, I just put it in the chat. This one is another generative design one that just based on this person's code, will every time we'll create a portrait of a wave of various colors that they chose. And what's cool is that like it looks like there's a ton of different colors, but really what they do, which is pretty smart, is they choose a color palette that they like, and then they add just a little bit of noise in the color variation to those colors, so that it looks like you have a like infinite number of colors, but really you just have like small variations on like 5 or 6 colors that you chose, which is really what like an artist does when painting in real life, right? Like usually your brush gets a little messy or you mix around colors a little bit, and this is like exactly what they did. Like that's like pretty cool in my opinion. And if you refresh it, it'll look completely different because they have this element of randomness inside. And this is another one where I would encourage you, and I hope I gave you all the link. I would encourage you to like find colors on coolers that you like, and plop them into this code and see what you can come out with. And then the last one that I have was my favorite one. This is my second favorite, but this is my favorite one. It's like, every year we usually have like a Jackson Pollock workshop, which is, sort of like brush throwing painting. It's very messy. This is not quite that, but the sketch that I'm about to send you really reminds me of that style. They call it Curvy Vine. And it's similar to the very first sketch we made in that all they're using is ellipses, but they're putting in elements of randomness, random brush strokes, and random physics in like explosiveness, so that if you drag your mouse around the screen, it'll start popping in these different green, yellow, or white colors, or even brown, and they'll eventually start exploding into different patterns or like directions. And literally after 30 seconds, you end up with something that just like looks phenomenal. Look at that. This looks like something out of The Incredibles, Monsters Inc. Very 50s style art. Very fun. Highly recommend. So that's all like I have to show you. And my hope was, now that we're almost at the hour, is that I gave you all a bunch of sketches and you all could either play around with in pure processing or just change around some of the code from the sketches that I sent you here and go off and have lots of fun art or share with the class some really, really fun things. Does anyone have one that they have been fixated on that they really like? Thank you, Alvin. Look at that. It's so pretty. But yeah, this is my favorite one so far. And you get this one's another one where you can like customize the color palette. So if you go in here, what's really cool is this one also doesn't have that many lines of code. It's 110, and they do a cool thing here where so I don't know if anybody is familiar with what we call object-oriented programming. So they created this class called a particle, and this is where they define their variations of colors. They add what they call a fade rate, which is a random number that they generate that then determines how quickly it moves, how like deeply or thinly it's sort of fuzzed over, and they add their color palette up here. So if you wanted to add your own colors, literally this is where to do it. Just put in your own colors and you'll go back to the painting. Oh, I hope it didn't delete mine. I guess we'll just have to do it now. No, I deleted it. That's okay. Oh, there we go. So does anyone want to share one of theirs? Nobody made art.
Cool.
That's okay if you did. We can be shy. A closed artist doesn't share their best work.
I'm really enjoying playing around with all these like cursor types, but I'm not very familiar with coding.
Yeah.
If I wanted to like change the shape and stuff, how could I look up like different options?
Oh,
with
totally. That's a great question. So, I assume you're talking about mouse press. So some like this. Let me like this one.
Yeah.
So that was one that actually, I was wondering what was the best way to like form this workshop, and one because I'm very tired, and two because I figured art is not as I don't think art is as fun as you're like following concrete instructions and writing a lot of code. So I figured we'd make it just more of like a explore these cool sketches that other people made and change them if you want. But this one, creating a brush stroke is something that like people dedicate a lot of time into. And so like, the entire company of Adobe who creates Photoshop and Illustrator, like that's what they make their business is in like writing code to make different types of brush strokes and stuff like that. So, we can do things that are similar. So let me first just make this a little bigger. So it's 720, so that it's a bigger screen. And so this is the money right here. Like this is where your shape is. So if you wanted to, what you could do is, so let's analyze this, right? So like it's saying line, mouse X, mouse Y, and then mouse X, mouse Y, minus 66 plus 66. So what this is saying is that, so if it was exactly mouse X and mouse Y, that would be right where our mouse is. But this is saying subtract the mouse X, 66 pixels from the mouse X on this one, but keep the Y, and then add 66 to the mouse X, but keep the Y the same. So this is our horizontal line right here, this first line. And this one is saying, keep the X the same, but subtract the Y and add the Y. So for example, just to edit this one, if we wanted to, what we could do is, let's say we wanted to make them much longer, or actually, you know what, much shorter. So let's make this 22, 22, 22, 22. Now what we'll have is much smaller little crosses in our screen to work with. And that seems like a little bit more manageable. So you can imagine, adding maybe a little slider or a clicker in the processing sketch. Then this is starting into like UX and GUI, that you can increase or decrease the size of your crossbar without having to write code, right? Which is like, an artist who uses Photoshop doesn't want to have to write code in order to change the brush size. This is how you would change, modify that. But let's say you wanted to make this so that it actually was a cross, not a plus sign. Well, what we could do is basically make each of these lines, just turn them a little bit, right? So instead of keeping the Y the same in this one's going minus 22 in the X. let's go minus 22 and minus 22 in the y, and then plus 22 in the x, and then plus 22 in the y. And then here, we'll just switch them. So we'll do minus 22 on that one, and we'll do plus 22 on that one. And in theory, this should give us x's instead of pluses. Yeah, and here we are. Because what I did is I just turned the, instead of saying a horizontal line and a positive line, I just added or subtracted pixels to both the x and the y values so that they turned a little bit. And now we have x's. And of course, you could always add more lines to the stroke. And then this one could be the positive line. This one could be the negative one. So now this one should look like a little asterisk. And it does. So of course you might be saying like, okay, yeah, but like what if we don't want to use just lines? We can go to processing documentation. And like any good coding language or coding software, all of this stuff exists here. So if you go into reference, shapes, here are some shapes that you can do. So 2D primitive shapes, you can do lines, but also points, quadrangles, rectangles, squares, triangles, ellipses, circles, or arcs. And then you can start to do a little bit more fancy stuff. So you can do box, sphere, Bezier curve. So let's just explore what like Bezier is. And it usually gives you examples of how to fill it. So here it's saying, make the stroke blackish, make a line horizontally that way, make a line a little lower, and then draw a Bezier from each of those points. And basically a Bezier curve is literally just like a series of X and Y points, and then it connects them in a nice way, right? So if you wanted your stroke to include like a nice little Bezier curve, you probably could do that too. And all you would do is like have this there and replace one of these values with mouse X or mouse Y, and it'd be good to go. So let's try it. I'm not sure this will work, but let's see if it does. So let's just replace my code here. So we got no fill, stroke 255, line. I'm going to comment these out because I don't think we need them. And then stroke. So just by itself, this creates a cute little line there. So now if we make one of these mouse X and mouse Y, what happens? This is literally me just experimenting. Sweet. So it takes one of the, this is cool. It like creates sort of like a little, sketchy curve here. So like it creates a line, but this curve ultimately stays the same up here. That's cool. So now you're gonna like this. I have an idea. Here, what we're gonna do is do mouse X minus 10, mouse Y plus 33, just saying random numbers, mouse X minus 2, mouse Y plus 200, and then those two can stay the same, whatever. Let's see what the heck happens now. Here we go. Yeah, cute little thing, huh? It's still too rigid for my taste. Multiply something. Yeah, see, so there, the multiplication comes in because it gets skinnier on this side and then wider as you get to the, so it multiplied mouse X by 2. And this is another type of thing where you could draw in that function where you say click, if mouse pressed, turn it white, if mouse not pressed, turn it black. That's how you could, I hope that answers your question as to like, how would you start to make different shapes and colors? And it's like, it's all math, which is like the crazy thing. It's just like, somebody had to do a lot of math and figuring out like how to fuck around with numbers to make things look really nice. Any other thoughts or questions?
Does processing itself have like libraries for sensors and IO stuff, or like would you have to? Uh, yeah.
So right in here, they have so many libraries. So in some of the things you asked about before, so you can export to PDF, you can read images from a camera, or different types of cameras. We haven't done projects here at the CID where people use processing and they interact with like a microscope, which is it's just a camera, but it has a little bit more functionality with their zoom and things like that. Transport serial data, receive network information, and these are just like the built-in libraries. Other people have created libraries for 3D animation using different languages, creating typography, doing geometry, and I have not by any means used like all these, but this one's called QuizyCam. So if you're using a super simple FPS camera, you can like do either like Jason Bourne shake or super stabilized something. What else? Everything will be inverse kinematics. That's a cool library for doing, cool physics stuff. Planetarium. And then if you go to animation, you've got all of these ones. Data processing. Daniel Schiffman made some of the libraries. So looks like Daniel made one for reading QR codes or creating QR codes. Raw data of some synthesizer keyboard. That's cool. Filtered noisy signals. That's a useful library actually. Signal filter. So yes, there's tons of library GUIs, but actually these are really useful to use. I should tell some of the students to use these because it's really they're for a lot of them are first years, but like they'll have this really cool looking physical project and then they'll show their GUI and it's just like this like ugly line. But yeah, you can do so many different things. If you work with hardware, so EECS or lots of other things, there's probably a lot of built-in libraries for a lot of things you might use. So let's see. This is the Mayo library. So I think that's I'm not really sure, but I think it's like a sort of camera robotic device. Leap Motion. What else? Apple Light, iTribe, Arduino. But only if you use Fermata. If you use IO, it's got a lot of stuff on here. So really, really cool stuff. Some more intense math stuff. Simulation. Oh, they even have Box 2D. Has anyone heard of Box 2D before? So in the world of like evolutionary artificial intelligence algorithms, they created this program called Boxcar, which is just a way to simulate this idea of like survival of the fittest within artificial intelligence. They made this box roll down this like rocky hill and with a couple of wheels, and the wheels were shaped a certain size, and the body of the car was a mixture of different size squares and triangles. And what they did is they just had it roll down and see how far it could go, and they it got to a certain point, see Adam, and then it would reset itself with different shapes, and try again, and they would say, all right, which one did the best? Let's make 30 more iterations of that one, but similar, and then they basically just keep trying to make the optimal car. So Box 2D is basically just like a physics simulator for creating that sort of environment. So lots of really cool stuff, and that's all I have today. But I hope it was a fun introduction to processing and digital art for some of you, if you hadn't already played around with it.